Hello, this is a short video presentation for my poster, Aspects of Quantum Gravity in the Standard Model from Nonnoetherian Spacetime, for the conference Quantum Spacetime in the Renormalization Group. Nonnoetherian spacetime is a Lorentzian manifold that is modified by defining the world line of a fundamental classical particle to be a causal curve with no distinct interior points. Such a one-dimensional event is called a pointal curve and has no tangent space. This feature gives rise to electric and color charge. Let M tilde be a Lorentzian manifold, which we call emergent spacetime. Let S be a collection of causal curves in M tilde called pointal curves. We declare 2 points, x and y, to be equivalent if there is a pointal curve that contains them, and extend the equivalence transitively. We define space-time to be the set of equivalence classes and denote this by M. In our model, we consider pointal curves alpha that are closed segments of helices centered about causal geodesics beta. Let omega be the angular frequency of alpha in the inertial frame of beta. Then we define the form momentum of alpha by the Planck-de Broglie relation in the direction of beta, shown here. Suppose alpha is a pointal curve whose central world line beta is a time-like geodesic. In the inertial frame of beta, alpha is a circular trajectory of radius r, angular frequency omega, and tangential velocity v. We define the mass m of alpha to be its curvature, 1 over r. Consequently, the energy E naught of alpha in the inertial frame of beta is given by E naught equals mvc. A pointal curve is on shell if and only if v equals c. We thus obtain a description of off-shell particles that does not violate relativity. P squared always equals E naught squared. A pointal curve alpha is a continuum of distinct points alpha t in emergent spacetime m tilde, and a single point in spacetime m. Thus, there is no tangent vector along alpha and m, although there is a tangent vector tau along alpha and m tilde. But this 4 vector is not uniquely determined by the motion of the corresponding particle, because fundamentally time does not flow along its world line. There is an ambiguity in the choice of sign. We identify this choice of sign with the electric charge of alpha, and denote it by sign of alpha. In our paper, we show that quark color charge, as well as the allowable combinations into mesons and baryons, arises from the ambiguity of the Frenet frame along alpha and m tilde. We want to represent pointal curves by chiral spinors. So recall that the generators of the Lorentz algebra, namely the 3 rotations and 3 boosts, admit linear combinations that decompose the Lorentz-Lie algebra into a direct sum of 2 copies of SU2. The chirality of a pointal curve alpha is specified by which SU2 subgroup its associated linear combination, shown here, belongs. Setting chi of alpha equal to sine alpha times sine of omega, we have that the chirality left or right is given by the sine of chi of alpha. From E naught equals mvc, we propose a Lagrangian density for pointal curves, shown here, where the derivative of the tangential speed v is with respect to the arc length and not with respect to time. By the variability of v, the classical equations of motion of L coincide with certain non-vacuum quantum motion determined by the path integral of the free Dirac Lagrangian. Now, an apex is a point x in m tilde where the chirality of a pointal curve is flipped, given by the only interaction term of the Lagrangian. By the relation chi alpha equals sine alpha times sine omega, either the time orientation, that is the electric charge, of alpha is flipped, or the sine of omega is flipped. In the first case, an apex is the creation or annihilation of 2 pointal curves of opposite charge. In our paper, the standard model particles are modeled by bound states of pointtal curves. In this example, we have an electron emitting 2 photons, and the 2 apexes in the scattering are circled, and the corresponding Feynman diagram is shown on the right. The absence of the chiral mass terms in the Dirac-Lagrangian implies that the pointtal particles represented by psi L and psi R do not source gravitation as they propagate. The Einstein equation on emergent spacetime, m tilde, is therefore given as shown, where 1a is the indicator function supported on the apexes in m tilde. This modification resolves Bohr's famous Gedanken experiment. To note, this is similar to the semi-classical Einstein equation. The classical Einstein equation is thus recovered in the classical limit where energy and momentum are measured at each point of m tilde. Thank you very much for listening.